Hello all, in this particular video we'll be learning about the concept of astable multivibrator. So to begin with the experiment, so this is your analog experiment, that is which is present in your part A of your syllabus. Astable multivibrator, it's an electronic circuit which does not reside stable even at any phase. So either at zero state or at the one state, it will not be stable, which is called as your astable multivibrator. So to begin with the circuit, I would like to show you the output of the experiment first, and then we would like to demonstrate you how to build the circuit. This is the output of the experiment in which you can observe two things. One is your T on and second is your T off. So here in this case, you can clearly see that your T on is greater than your T off. So this case is called as duty cycle. So duty cycle is at which your rate of change is happening here. So duty cycle, if you observe here, T on is greater than T off here. So it is more than duty cycle is more than 50%. Now let's consider our second case. Here in this case, you can clearly see that your T on and T off is almost same. So this is your duty cycle which is equal to your 50%. This is your third case which you can see here, in which your T off value is greater than your T on. So this is the output for which your duty cycle is greater than your 50%. So which is less than 50%, sorry. So these are all the output of the given circuit. Now let's go back and start deriving the design part of your astable multivibrator. The IC which is used for astable multivibrator is 555 timer. We also call it as IC 555. It is an 8-pin IC in which the configuration goes like this. Your first pin is connected to ground, second is connected to your trigger, third is output pin, fourth is reset pin, fifth is the voltage in which you are controlling, sixth is the maximum threshold voltage, seventh is the discharge, and eighth is connected to your VCC. As we have said, there are three stages or three cases to calculate the duty cycle for greater than 50, equal to 50 and less than 50. Let's consider your case 1. So in case 1, we have two things. One is T on and T off. So this is for the duty cycle which is greater than 50%. So to calculate that duty cycle, we have two things. One is T on and T off. Formula to find T on and T off is 0.695 into R1 plus R2 into C, where C is my capacitance, R1 and R2 are my resistance value. T off is equal to 0.695 R2C. The duty cycle is calculated by T on divided by T on plus T off. Assuming that my one resistance value is 10 kilo ohm, I want to find out the second resistance with the capacitance value of 0.1 microfarad. So since I am taking the value of the duty cycle as 75%, which is greater than your 50% duty cycle, in this case 0.75 is equal to 695 into R1 plus R2 into C divided by T on plus T off again. Substituting these values, we'll be getting 0.75 which is equal to R1 plus R2 divided by R1 plus 2R2, which is equal to 0.75 into R1 plus 2R2, which is equal to R1 plus R2. So in the next step, it will become, if you cross multiply it, 0.75 into 1000 plus 2R2 is equal to 1000 plus R2. So which is equal to 7 7500 plus 1.5 R2, which is equal to 1000 plus R2, which is equal to 0.5 R2, that is 25,000. R2 is equal to this divided by this, which is equal to 5000 ohms or 5 kilo ohm. So this is your first case for which the duty cycle is greater than 50%. We have taken the value, that is 75%. Now let's construct the circuit for the same. So this is the circuit diagram which you are seeing. So this is the 555 timer which we are having, where your second and sixth pin is shorted. Your second pin is your trigger and sixth is your threshold. Seventh pin will be acting as discharge point. So your 2 and 6 are shorted, in which I have connected resistors, that is R1 and R2. My R1 is 10 kilo ohm and R2 is 5 kilo ohm in series with a capacitor of 0.1 microfarad, which is connected to your first pin. Fifth pin, the control voltage, so we have the fifth pin, that is 0.01 microfarad, which is connected to ground. Third pin is connected to Vout, and here the another point of your resistor is connected to your VCC, that is plus 5 volts. So this is all about your first case. The same applies to your second and third case. Let's go ahead with your second case now. So for duty cycle, which is equal to 50%, so formula remains same, T on and T off. So here my duty cycle will be 0.5, which is equal to 0.7 into R1 into C divided by your T on and T off. If you calculate this, we'll be getting R2 is equal to 10 into 10 power 3, which is nothing but your R1 and R2 are same. In this case, we'll be constructing the circuit as follows. So this is the circuit for duty cycle which is equal to 50%. The rest all other circuit remains the same. So there should be a connection here. Okay. So apart from this everything, I have connected your positive end of the diode with 7th pin and your negative end of the diode with 2 and 6 here. So this is about your second case where duty cycle is equal to 50%. Let's consider the duty cycle where we have less than 50%. Let's say we have 45% of duty cycle. So 45% will be getting approximately, which is equal to resistance. So T on and T off, after calculating this, will be getting around 45% duty cycle. So this is the circuit diagram of the third case in which my duty cycle is less than 50%. Here my resistance value will be changing. My R1 value is 1 kilo ohm, my R2 value is 1.2 kilo ohm, and my capacitance value is 0.1 microfarad. Rest all other things remains the same. So this is all about your Astable multivibrator circuit. When we come with the lab part, that is the demonstration with respect to your trainer kit, you will be clearly understanding the construction of Astable multivibrator. Thank you.